Assalamualaikum guys, this is Najmunisha Shah. Today I am going to speak about what the linear electron pair geometry. Our previous presentation I have spoke about what the Vesper theory, and according to the Vesper theory we lead to the electron pair geometry. Now we are going to speak about what under the electron pair geometry we have the different type of the shapes. So that's what is going to be here. So now let's be more to our subject. What is mean by the electron pair geometry? Yes, we know how the repulsive units is distributed according to the spatial arrangement. You have ended with what the electron pair geometry and how we live into that linear electron pair geometry. When you have the two Vesper units present around the central atom, that word is very, very important about what the two Vesper unit or the repulsion. If you have the two Vesper unit, then we are speaking what? Yes, that is what in this situation, the two Vesper unit, not the lone pair, both are bonding pair. Ultimately, we are naming that species as linear. Should be very careful about that, right? Though the geometry of linear, yes, the shape also linear, there is no more change. Why? The two Vesper units is leads to what? The bonding pair, not forming the lone pair. And you will end up with the shape of the linear. And the following tables provide the more examples for the linear molecule. Let's we step into the example one by one. The first example is hydrogen cyanide, HCN. The table is given. So first, whenever I already said, if you want to determine the geometry and the shape, the Lewis dot dash structure is very, very important. So what should be the Lewis dot dash structure of the HCN? Yes, it's clearly given, right? Your carbon is bonded with the nitrogen and as well as the hydrogen. Though it is a triple bond, right? Though it is a triple bond, we are considered as in what? One Vesper unit or repulsion unit. And the carbon hydrogen are having the single bond, that is also one Vesper unit. Ultimately, the angle is least to what? 180 degrees. Now you can see the shape geometry of the linear and the shape of linear. Why? The carbon doesn't contain any lone pair, only the bonding pair, so that the shape is linear. Let's move on to the next example. What is the iron? NO2 plus. Now I am speaking about iron. The NO2 plus is also not new for you all. Yes, the NO2 plus, the nitrogen is containing the positive charge on that. Even that the positive charge, it doesn't matter. We are talking about what? The bonding pairs, right? Or lone pair. There is no more lone pair, only two bonding pair. Therefore, your angle is again the 180 degree. Actually, the nitrogen is appear like this. You can see. This is actual, the blue color for what? N. This red color for the oxygen. What the shape is this? Yes, that is what you are having around the central atom. You are having what? The two Vesper unit. So therefore, you are having what is this angle? It's a 180 degree. The shape is linear. So next example, carbon dioxide. So whenever you want to describe about what the shape, the geometry of the you should be able to draw the Lewis dot structure. Let's we draw this carbon dioxide. How we are going to approach the Lewis dot structure? Just for the recall of what your Lewis dot structure, what we studied under 2.2, right? So let's try. Give me a second. Let's use the annotation. Yes, good. So when you speak about the carbon dioxide, you or the person should understand the central atom. The central atom is carbon and these oxygen bonding here. So I have first step is I have drawn the skeleton. The second step, I should find the valency electrons around each atom. The carbon containing the 4 electrons, the oxygen containing the 6 electrons. You have 2 oxygen, therefore 6 into 2, 12 electrons. If you add together, you will end up with the 16 electrons. So what is your next step is, you have to distribute the 16 electrons among these molecules, right, atoms. So what you want to do is, first you have to check, you have the 2 bonds. Each one bond is associated with one pair of electrons. Here you have the 2 bonds, so next step, 2 into 2 electron, that means you will end up with the 4 electrons. So subtract the 4 electrons. Now you have only 12 electrons. The next step is, what you want to do is, you have to distribute the electrons for the highest electron negativity atom, not electropositive atom. Here carbon is a electropositive ion. Yes, the oxygen is the highest electronegativity ion, so I am providing the lone pair for the oxygen. Okay, 6 into 12. So 12 minus 12 electron 0. This part is completed. Right. And next, what is our responsibility? We have to check the octet rule and the valency electron. So when you check the octet rule, right, when you check the octet rule, the oxygen 2, 4, 6, 8, the octet rule is correct. The carbon only 2, 4, not obeying the octet rule. Again, it's oxygen obeying the octet rule. Check your valency electron. 2, 4, 6, 7, 1 is 6, so minus. Here carbon, yes, 1, 2, 2 is less, so 2 plus. Here again 7, 1 is 6, minus. So the too much of the charge separation, not valence electron not completing the octet rule, we have to move the lone pair for their stability. So we are moving this oxygen pair to get the stability and to obtain the octet rule. So what should be there? Carbon. Yes. Now, because of the movement of the oxygen double bond, here double bond, and one has moved, one pair of electron has moved, so you will end up with 4 pair of electrons. Now let's check the valency electrons and the electron pair geometry. So when you check the octet rule for the oxygen, 2, 4, 6, 8, yes, octet rule is right. The carbon 2, 4, 6, 8, yes, that is also right. And again this oxygen 8, right. Valency electron shell 2, 4, 6, yes, the 6 electron, that is correct. Carbon 1, 2, 3, 4, yes, that is also correct. Here also again 6, correct. And this is what your stable configuration carbon dioxide. This is the way to draw the Lewis dot structure. I just recall what we had done under 2.2. Alright. Okay, so let's find. So from this, can you say, how can you determine the angle? Yes, that is what you are having only the 2 double bonds. That means you have the 2 repulsion. You have the 2 repulsion unit. So if you have the 2 repulsion unit, you can say you will end up with 180 degree. So the shape and the geometry also. That's all. So what should be the Lewis dot dash structure of the carbon dioxide? Simply we have found, right, that is CO2. And the angle, yes, that is also 180 degree. The linear having the 2 repulsion units. And this is how actually carbon dioxide is, you can see. The carbon in the black in color, right, the oxygen in same. So this is what you are having the 2 Western units. And ultimately the geometry and the shape is linear. The final one is the beryllium fluoride. So So the beryllium chloride seems to be similar, right? This is your Lewis structure having the two chlorine bonding, right? So ultimately it's end up with what? The shape is 180 degree. Actually your beryllium chloride is something like this. The green color is what? Beryllium, the blue white color is what? Chlorine. Yes, yes. Again, I am talking about this. You are having the two repulsion unit and simply that the shape is. So we have gone the different example to understand about what the shape and the geometry of linear. So with that, I conclude this presentation, guys. Thank you very much. Okay. So we will speak about the next electron pair geometry, that is having the three repulsion unit trigonal canal. Right. So we will see you with new presentation. Until that, see you. Bye bye. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, guys.